We wanted you to be able to learn. Well, this morning we're very fortunate to have Dr. Thom Mason come and speak to us this morning. And to introduce him, I'm going to introduce Jim Roberto, who is the Associate Lab Director for Science and Technology Partnerships at Oak Ridge National Laboratory.
Good morning, and thank you, John. I'd like to introduce Thom. He was born in Nova Scotia, graduated from Dalhousie University, and received his PhD in condensed matter physics from McMaster University. After completing his PhD, he was a postdoctoral fellow at AT&T Bell Laboratories, then a senior scientist at Riso National Laboratory in Denmark, and finally a faculty member in the Department of Physics at the University of Toronto. He joined Oak Ridge National Laboratory in 1998 as the scientific director of the Spallation Neutron Source Project, and in 2001 he was named Associate Laboratory Director for the SNS, where he was responsible for overseeing the on-time, on-budget delivery of this $1.4 billion project. In 2007, Thom was named Director of Oak Ridge National Laboratory and President and CEO of UT Battelle. His research background is in neutron scattering on magnetic and superconducting materials. As lab director, he has a direct interest in advancing materials, neutron, nuclear, and computational science to drive innovation and technical solutions in energy and global security. In addition, as director, he has championed new initiatives at Oak Ridge in entrepreneurship, technology transfer, economic development, and graduate education. Please join me in welcoming Thom Mason to the 2012 Entrepreneurial Imperative. Thom?
Well, thank you, Jim. Welcome, everyone, to Day 2 of Entrepreneurial Imperative 2012. Oak Ridge National Lab is proud to be a co-sponsor of this event, and as a mission-driven laboratory, which Oak Ridge has really been since 1943, it's our goal to deliver discovery and innovation to help solve really challenging problems in energy and security. And when we do that well, that's how we provide our return to our investors, who are the taxpayers. And part of that involves hopefully finding ideas, finding innovations that have some commercial potential, although in the end we're not the ones who will commercialize and take them to market. We don't build anything and we don't sell anything. So we have to transfer our ideas to the marketplace, and when that happens successfully, it does create economic opportunity, and there are some great examples over the course of our history, and I think we've got some pretty exciting stuff going on right now that will become the future examples in the next 5, 10, 20, who knows how many years. And as part of that, we've had a long-standing partnership with Tech 2020. It's really an important part of our tech transfer toolkit. The Center for Entrepreneurial Growth was launched in 2000 with support from UT Battelle in the state of Tennessee. It was actually, I think, one of the ideas that came out of the proposal to manage the lab that UT Battelle put together in 1999 that led to the awarding of the management and operating contracts in March of 2000. And more recently, our activities focused on increasing our impact include the Spark Technology Forum. This is an effort to try and discern the business potential of promising new technologies. The Bridging the Gap exercise, which is really reaching out to investors and entrepreneurs. And more recently, the investment of discretionary funds to seed promising projects. We have something we call the Laboratory Directed Research and Development Program, which is kind of our internal venture capital. And traditionally, it's been focused on really outstanding science and engineering, And that continues, but we've added a program called Launch, which has got to be focused on really outstanding science and engineering where we think there's a market potential. So it's got a little bit of an extra wrinkle around it, and it's actually managed with that in mind. It's into its second year now, so I don't think we can yet point to the impacts of changing the focus in the rearview mirror, but we're going to be in the point, I think, in a few years where we can see whether or not this changed the dynamic. We've also made some changes in our policies to help our staff engage in entrepreneurial activities. An example would be the new company founded called Network Sim, where our researchers, Fani Karaganti and James Nutaro, who actually won an R&D 100 award for that technology, are able to participate in the launching of that company but still stay employees of the lab. This is something that's not a new idea. In fact, probably the original startup coming out of Oak Ridge National Lab was Ortec back in the 60s, and that was essentially an entrepreneurial activity by lab employees. It was kind of what you might call a bootleg effort, and so what we've tried to do now is recognize in our policies that there are ways that we can do this and manage the conflict of interest, and hopefully by allowing our researchers to stay engaged with companies that flow from their ideas, increase the chances of success. We don't have to put up a hard stop where we say, okay, you're going to leave or you're going to stay but not have ongoing interactions. We're also piloting something called the Agreement to Commercialize Technology, which is a new mechanism the Department of Energy has instituted to hopefully speed up the consummation of deals with the private sector. One of the common complaints that I hear when I talk to companies, large and small, is that it just takes too long to reach an agreement because of the wrangling over the standard terms and conditions that come with doing a deal with any government entity. And so this ACT mechanism allows us to have a little bit more flexibility in the nature of those agreements, the theory being that flexibility will lead to speed. And so we'll see how that goes. We also have high hopes for the graduate students at the Bredesen Center for Interdisciplinary Research and Education, which is the name that we've put on the new graduate program that we've instituted with the University of Tennessee at Knoxville. This is now going into its second year. Starting in September, we had the second round of students going into the program. And of course, they'll be pursuing graduate degrees across a range of scientific and engineering disciplines, but embedded in the design of those graduate programs right from the start was the possibility for an entrepreneurial component. This is a really outstanding group of students who've entered both the first and second year and will be progressing through their graduate degrees, conducting their thesis research at the lab, working with university faculty and laboratory staff, and they bring a set of fresh eyes. They're may be a little bit more able to take risks. I like to remind people that Google was not started by Stanford University professors. It was started by Stanford University graduate students. And it's a lot easier to live in a garage and eat ramen noodles if that's what you've been doing anyway. So we'll see how that plays out in terms of giving us a new mechanism for increasing the ability to have companies started up using technology developed at the research institutions in the region. There are a variety of different mechanisms to meet different needs. We can provide technology assistance. We often license the results of our research to large companies. An example of this would be the recent license we made to Carpenter Technology, a specialty metals company, for alumina forming austenitic steel. and they are in the process of taking that to market. But we also license to startup companies, and this is, of course, the area where Tech 2020 plays a key role. And it may take time for these things to achieve their potential, but they can be exceptionally productive. I think our largest license at the moment in terms of revenue is for something called Lab on a Chip, and that's a microfluidic technology that was developed starting in the early 90s. I think it actually began with some of that same LDRD funding that I mentioned a while back, so went from idea in the early 90s to a startup with a license in about 1995. That startup had an IPO in about early 2000s, 2001, 2003. It merged with another company, and in 2010 it was sold to Perkin-Elmer, which is a large manufacturer and distributor of scientific equipment, for $600 million. So that's getting pretty close to the threshold I would set for something that you might call a big impact. But you'll note it did take a while. As I said, it started with some LDRD investments in about 1991, and so it was almost 20 years to grow and improve and restructure, and there were a few lawsuits along the way. But I think that path is probably not that atypical. So conferences like this one are key to connecting innovators and entrepreneurs. I'd like to thank the host sponsors, Tech 2020 and Launch Tennessee, and please enjoy the remainder of the conference.
Thank you, Dr. Mason. Oak Ridge National Laboratory plays a critical role in our community, as well as a critical role in the technology assets that we have here in the region. So we're going to talk a little bit next via a panel with a commercialization panel that's going to be led by Tom Rogers of Oak Ridge National Laboratory. And so if I could get the people who are on that panel to work their way up here. I see Mark and Maha are in the back. They're going to have to make their whole run. No. But so I'm going to, if y'all come up and get your seats and, and microphones, and we'll get going from there. Thanks.
Well, good morning. My name is Thom Rogers, the Director of Industrial Partnerships and Economic Development at the Oak Ridge National Laboratory. And the panel that I'm going to lead today, the title that Sean gave us was Breaking Down Barriers in Tech Transfer and Commercialization. We've got a very good panel of people who can talk to that topic. I'm going to briefly introduce them, then take a seat with them and ask them a series of questions. We'll along the way be open to questions from the audience, so if you would, if you'll come to one of the microphones, I'll keep an eye open for you and make sure that you get a chance to talk to them as well. We'll start with Maha. Maha Krishnamurthy is a licensing associate for the University of Tennessee's Research Foundation in the Knoxville office. She's responsible for intellectual property portfolio management and commercialization of UT's technologies from plant biotechnology, the College of Engineering, and the College of Arts and Sciences. Prior to joining UTRF, Maha was an IP commercialization, licensing, and maturation consultant with clients such as the Oak Ridge National Laboratory, and was a postdoc research associate at UT, published over 20 top-cited peer-reviewed papers. Maha has a PhD in physics as well as an MBA. Next we have John Taylor. John is the Director of Program Management at the National Institute for Hometown Security in Somerset, Kentucky. NIHS provides program management and commercialization services to the Department of Homeland Security. As Director of Program Management, John works collaboratively with DHS to develop contracts with Kentucky Institutes of Higher Learning and to establish and monitor performance targets for each of the funding projects. John has a Bachelor's of Science degree in Professional Aeronautics from Emory-Riddle University and an MBA from Xavier University in Cincinnati. Next we have Tom Berg. Tom is the Y12 Program Director for Partnerships and Technology Transfer. He has more than 25 years experience in tech transfer and business development for technology organizations including government, aerospace, and healthcare. The Y12 Partnerships and Technology Transfer Program has doubled the number of invention disclosures recently, reinstituted participation in the R&D 100 awards, and implemented advanced practices such as crowdsourcing, social media, and open innovation. Tom earned a BS in biochemical engineering and an MBA from the University of Wisconsin and is currently working on a PhD in systems design at the University of Tennessee. And finally, my colleague Mark Reeves. Mark is the Associate Director for Commercializations in the Partnerships Directorate at ORNL. He's responsible for the stewardship and commercial licensing of a broad portfolio of technologies in power electronics, superconductivity, wireless communications, image analysis, transportation, robotics, and nuclear medicine. Mark earned a BS degree in biology and chemistry at the University of North Alabama, a PhD in microbial physiology and biochemistry at the University of Tennessee, and an MBA from Colorado State University. So obviously we have a very talented and well-educated panel, and I'm going to go ahead and take a seat and we'll start a conversation. So I have a number of questions for you and would like to hear your observations about them. And Maha, I'm going to start with you. First question that I'd like you to share with the audience is, give us an example of a recent technology transfer success story from your institution and the keys to success, both from your staff and for your partner.
This year was a very productive and a very good year for us. We did have 9 startups, the whole UTRF, not just Knoxville, but also our partner out in Memphis. And we did a lot of patenting, typical license deals. But the one that is nearest and dearest to me is the one that we did with launching an app. And it starts off with an inventor who came to us and said she has this fantastic idea. She's actually gone and talked to a lot of landscapers, and she's from plant biotechnology, and spoke to a lot of nursery owners and said, these people have this problem. They don't pest management, soil rotation. If you have a big garden, you know what I'm talking about. And I stared at her and I went, seriously? And she goes, yeah, and I'm going to make an app. And so she started putting together all this information, and she realized that she's not an expert. And so she sourced out from 7 different southeastern United States universities faculty members. So there were 10 faculty members who contributed to the app from 7 different universities. And then she said, now we have all of this information and we would like to work with somebody who can help develop the app. So we had to go and find a partner, because these are all biologists, and so we had to find a partner who could actually make the app and write the code and work with them, put the contracts in place. But at the same time, to remember, there are 7 faculty members from 7 different institutions. So you have to put an interinstitutional agreement among all the different tech transfer offices. And if you have worked with one tech transfer office and you think we're hard, it's fun to work with 7 of us and 7 different state schools. And so we did that, but everyone, when we sat in the room and we talked, on the phone, and everyone went, yeah, it's an app, it's not going to make much money. So nobody ever really negotiated the IIA. People just signed on to it, which was great for me. And then, so we finally managed to launch it, and so the inventor did a lot of surveys. She asked these people, at what price points would you go and download the app? And they told her, there's no advertisement coming in, we'll pay $40. If there is ads and all that, 10. And so we have two different versions, the IPM Pro and the IPM Lite. And we launched it in Apple and in the Android platform. And it took off. I remember our business manager coming in and said, did you see this? In 2 weeks, we have something like 50 downloads. You go, wow. Now you can do 50 times 40, and within 2 weeks, that's the amount of money we made with barely any cost down. And one of the biggest landscaping companies in the country contacted us and said, can you tweak this app for our particular application? And we have 5,000 franchises that we want to deploy this app to. And we go, oh. And he goes, you got to tweak it this way. Now, then there's another company that called us up and said, can you tweak it this way? Now it suddenly became a business which our inventors are not in a place to do. So this was the success was working with the inventors, trying to get this app, even though it felt like it's not going to go anywhere, but she was really, truly believed in it. And what it also taught us was that there's a true market need. At the end, the customer is always right. And when they really say, yes, we like it, and you go for it, it just takes off. So it was a win-win, and it's a great, personally to me it was a fantastic eye-opening, because to me it was all technology, and if it has a fantastic material, as a physicist I get all excited about it, but there's an app for this one.
Thanks, Maha. John, you want to share with us a success story from NIHS?
Sure. The Department of Homeland Security Science and Technology Directorate, they wanted the capability to stabilize shock damaged structures in the event of something catastrophic, something like an Oklahoma City bombing, or even perhaps the tsunami in Japan and the nuclear facilities. And for obvious reasons, to protect emergency responders and whatnot. And we contracted with the University of Kentucky Center for Applied Energy Research, and they already have a commercialization partner, or a commercial partner, Minova of North America, and they work in the cements. And what they've done is they've developed a shotcrete delivered cement, which if you're not familiar with it, it's essentially a spray-on concrete with a fire hose. The unique capabilities of this concrete are that it sticks to anything, and that's kind of different than your normal Portland cements and whatnot. So it's got that unique capability, and also for the quick reaction time, it can achieve 2,500 psi compressive strength in 15 minutes, and it can achieve over half of its 11,000 psi compressive strength within 3 hours. So you can spray on anything, you don't need any molds or setups, and it's a very successful capability, very successful concrete development. And keys to success, while it's a neat capability, would FEMA buy and stockpile a bunch of that? I mean, would anybody play in that market or even want to develop it if it had no market other than the event of something catastrophic? Hopefully we never have that. But it's got keys to success. It's got to have a commercial viability, commercial capability. And the key to success on this one is that Minova is in the mining business. And what a neat product to shore up mines and make mines safe. So they went hand in hand with this development. They get this commercial capability. And since it's developed and ready and available, it's available to Homeland Security should they call on its capability. So that's the big key to success on that.
Thanks, John. Tom Berg, you got a lot of good things going on over there at the Y-12 National Security Complex. How about a recent success story?
Oh, it's so hard to pick, right?
That's right.
I guess the ones that come to mind is, and for those of you who aren't intimately familiar with Y-12, we tend to be more on the applied end of the spectrum, going from basic research to tangible inventions, if you want to call them that. And so the ones that come to mind is a couple of inventions that Jeremy Benton licensed to a local company. and it was a company that started up a separate organization to actually commercialize this, and they're related to security, and of course that kind of makes sense for Y12. One is a special kind of rotogate that the harder you push, the more it pushes back. And so for somebody like me who's way too highly caffeinated and goes charging through the turnstiles, I can verify that it really works. Because it stops and you don't, and we all understand inertia, and it leaves a mark. And the second, also a security device, relates to the opening and closing of gates, and a big thing for security is time delay, and it does that. And the big deal is not just the licensing of the technologies, but the partnership that we formed with the company. We continue to learn this lesson that it's not just throwing the technology over the transom. It's forming the relationship with the enterprise that licensed the technology, so you work with them and you get a place and you help develop the markets and develop an understanding of kind of the interaction that's required in order to have a successful transition of the technology to the commercial marketplace.
So Mark and I both work together at the Oak Ridge National Laboratory, the nation's largest science and energy lab. Mark, how about a recent success story and some of the keys to the success?
The interesting word in your question, Tom, is recent. Sometimes you have things that spring up overnight, but oftentimes the success stories, much like the one Thom Mason mentioned this morning, evolve over a long period of time. And the one I'm going to tell you about is a little bit in that category. We have a group of software developers and geographic information systems experts at the laboratory who, for 10 years or so, probably more than that, have been employed by a Department of Defense unit to develop a data set that they call Landscan. It's a global population data set. I saw Eric Dobson come in. Eric's father, Jerry, who was a geographer at the laboratory for years and was actually the father of Landscan, so started this thing, and has since been carried on by others at the lab since Jerry left for the University of Kansas. But this data set is produced every year, and they gather, the folks collect population information from all over the world and put that into a data set that can be used as a layer within a GIS system, so that when somebody wants to put up a big map of characterization of the world in various ways, economy, soil type, vegetation, whatever, one of the layers you can put on there is population, so you can mark the major population centers, you can see how they change over time, that sort of thing. My former colleague at the laboratory, Ashok Chowdhury, became sort of intrigued by that and became convinced that it poised for a big commercial success. I was a little bit skeptical at the time, but I worked with Ashok, and we developed a strategy for how we were going to make this thing a big splash in the marketplace for our particular licensing program. One of the pieces of that strategy was to make it free for educational purposes only to bona fide educational institutions worldwide. The thinking that Ashok had was, if we do that, within 5 years or so, it will become the standard. Every student who graduates in the GIS area will be familiar with it, and when they go into the commercial world, will want to use it for the purposes that they go with their career. We also made it available at fairly low cost to nonprofits, to state and local governments, and of course it's free to the federal government. And we pushed it very hard. We aggressively marketed it, and we did a lot of little bitty license deals that were kind of labor intensive over the years. But Ashok's vision for this thing always was that if the market for it grew big enough, a big software distributor would want to take it and take it to market. Well, that's happened. Just in the last year or so, even though Ashok has left and gone to Vanderbilt, whose team is 7-4, by the way, and I still give him credit for the vision he had about this thing, because it's well on its way now to being a 6-figure royalty producer for our royalty stream at the laboratory. The first year or so we did it, if we took in $2,500, we were lucky. So it's the kind of thing, I guess the lesson is, have a vision, have a strategy, execute on it aggressively, but it takes time for these things to play out.
Mark's son, by the way, is going to the University of Notre Dame, so don't talk football with him.
This year.
This year. So, you know, as I look across the chairs here, collectively, you guys have a lot of experience in tech transfer, and it's a profession. So are there new trends that are emerging in tech transfer? Are you considering new partnering strategies or mechanisms? I mean, what for this audience, what are trends that are emerging that might interest them? And Mark, I'm going to start with the most experienced guy, which is you.
I'll mention a couple of things. Thom Mason mentioned one of them. The Department of Energy has done some soul searching in recent years about policies it's had in place for years, and do they still make sense, and should we think about changing those policies? If you've ever worked within the Department of Energy complex, you know that we make haste slowly, and so things take a while to come around. But a lot of things have happened in the last couple of years, and a couple of notable examples. And just for your information, we in our organization consider technology transfer to be much broader than just intellectual property protection and licensing. Our Work for Others program, our research partnership program through CRADAs is all part of that. This ACT program, Agreement to Commercialize Technology, is a mechanism by which the Department of Energy has granted the laboratories, through a pilot program, by the way, the authority to enter into agreements to do work for private firms, but without some of the somewhat onerous terms that have historically been mandated by the DOE in those agreements. So the agreement between, in our case, UT Battelle, the contractor for the laboratory, and the firm who needs the work done would look much more like a commercial contract. UT Battelle would have a separate agreement with the Department of Energy where we take on a lot of those onerous terms and say we'll handle that blind to the person who's hiring us to do the work. And then UT Battelle gets to charge a fee because we're taking on additional risk for doing that. We've yet to do the first agreement. We actually don't have the authority yet from DOE. We expect it soon. So we don't know what the upside of that program is, but to me the beauty is that the Department of Energy is willing to rethink some traditional positions it's had on the way we do business with the private world. Another good example of that, which is in place, for years the Department of Energy mandated in our Work for Others agreements a term called march-in rights. And what it essentially said was, if new technology, new patentable technology is developed under a Work for Others agreement, and the sponsor of that Work for Others agreement takes title to that, but the government later on has a need for that technology and it's not being made available in the marketplace, the government can march in, take that technology and have it manufactured for itself because there's a need there. There's some doubt as to whether that policy has been in place throughout the federal government forever. There's some doubt as to whether it's ever been exercised. I think maybe there's been one example at NIH where it was exercised in the case of a drug. But it's such a rare occurrence, and every time we do an agreement with a company, we wind up having to explain that over and over and why it's there and why it's not an impediment. The Department of Energy has just recently said, let's get rid of that. Let's take that out. It makes it a little easier to negotiate an agreement with a private firm. So there's a couple of examples.
The good ones. Tom, any new trends?
Yeah, I think Mark did a great job at explaining them, and Y12 and ORNL are kindred spirits in the fact that we both report up to Department of Energy. I think another one is DOE is, what was that phrase you used? We make haste slowly. We're very practiced in our bureaucratic approach, kind of. And we're very good at it. One of the things that we're changing is there's been some feedback from the private sector that we could be faster at putting our cooperative research and development agreements, CRADAs, in place. And so the Department of Energy is working on a mechanism that, in essence, they get pre-approved through the government side, who have to approve the statement of work. So in essence, you can approve a broad statement of work for a whole variety of CRADAs. And if that gets put in place, and our expectation is that, it is, and the first question is how is it going to be enacted, that should expedite the process of getting CRADAs in place between us and the private sector. I think another one is, I think we'll see some changes driven by a variety of factors on how to streamline the licensing process. The various DOE sites have enacted a couple of different approaches to licensing. At Y12, we've done the XTL. It was actually developed by Tammy Graham, who runs that part of our office. And that's a way to have what amounts to a very straightforward, very simple license put in place, principally for startups or small businesses, really startups. And so it's got a very low, very favorable terms, upfront fees, and what we're saying is that we'll buy into the risk for someone licensing the technology and benefit along with the partner downstream if it happens to be successful. Probably the last thing, and kind of throw this out, is the equivalent of Obamacare for licensing is the new changes to the patent law. And so what we're not sure about is what the impact's going to be. For those of you who don't know, it used to be first to invent. So you could have sat in your basement and wrote in your notebook, which I'm sure as inventors you all do, right? And you all get it reviewed and you all get it signed. We all know that you do that. Well, now it's first to file. And just like with Obamacare, the jury's out on what the impact's going to be. So I'm looking forward to significant changes later on what the impact of that might be to our profession.
So, John, I think of the National Institute for Hometown Security as a bridge, a bridge between the Department of Homeland Security and colleges and universities in Kentucky. You've been at this for, I'm not sure how many years, several years. Are there things that you have learned and new ways that you're plying your trade?
We're experiencing similar improvements from the Department of Homeland Security in their contracting vehicle. We're actually operating under an OTA, another transaction agreement. And I think they were traditionally done under the Department of Defense where they could have more flexibility. We want to be quick with buying a capability, and we don't necessarily need to be under the burden of the onerous FARs, and laying out a process that could take you 1 to 2 years to put a contract in place, and then you've got to develop the thing, and here you are 7 years down the road still waiting for that capability that you want. The OTA gives flexibility in intellectual property, also in the process of awarding the contract. We do just that. We connect the dots between that DHS gap and the research capabilities to achieve it, and we'll have our list of the best capabilities in certain areas, and we'll match that up with they want this particular capability. This is the best research institution at accomplishing that. So we can do that without this bid process and comparative thing and this long drawn out thing. So that's something new and very beneficial to them, and helps us react very quickly to their need.
Maha, no football questions, I promise.
Please don't.
Anything new that you see from the university perspective?
So even the UTRF has been around for about 75 years. The whole staff at UTRF, licensing staff, it's been about a year and a half that I've been there for a year and a half, and our whole team is younger than that. But we have been trying a whole host of new things this year. One of the things we did was partnering with a Fortune 500 company, and we had this very interesting technology, research media. And so we contacted this company and said, are you all interested in licensing? And they said, this is fantastic. We don't know the market for it. So we discussed with them, and he said, okay, what about if we made a limited quantity of this material, and we give it to y'all under a MTA and a license agreement, and y'all try and sell it. But we will only make 1 liter in this case, and if it sells, and they'll be selling it in 10 ml vials, so 1 liter goes a long way. And they can try and sell it, so it lets them 2 things. One is the price point that the customer is willing to pay, which helps us to know what kinds of royalty rates we can charge them. And the second thing is, depending on how fast it sells, they'll also know how to set up their manufacturing, because as a university, we don't get into the manufacturing business. In fact, this 1 liter that we made, we said, this is a quality. We don't do quality control. We'll try to do our best, but I can't give you quality assurance like industry does. They said, fine. And they have taken it, and they'll sell it, And every 6 months they give us reports and we have to see where it goes. But they were so happy we did this one that for another chemical compound, they came back and said, I told them, will I be interested? They said, yes, let's try and do the same thing and see. So this is a great way for us to know two things. One is we file a provisional, we protect the technology. This company is going to try and sell it, and if it sells within that year, we know what royalty rates to charge them. We know whether we should go ahead and convert this provisional into a utility and take it from there. Another thing that we have been trying to push a lot is research licenses, where we give the technology to the licensee, and this is primarily in the field of ag biotechnology, where we license the gene because it's so early that the licensee wants to put it into their system to really see if it works. Can they scale it? Does it actually do what it's supposed to do in their system? And we give it for 2 years, and if at the end of the 2 years they'll come back and if it works, great, then we know what kind of a commercial license we're going to put in place. And if it doesn't work, then if these companies can't get it to work, the probability of somebody else trying to get this to work is very small. So these are some of the new things that we have tried this year.
Thanks, Maha. So we're going to throw this open for questions. Are there questions in the audience that you'd like to pose to any of these panelists? If not, I have another question.
We have none.
You've educated them. So my final question, and Maha, we'll start with you, is because you all represent different institutions, and while some of them are based on the Department of Energy or the Department of Homeland Security, others are university, what advice would you give to people in the audience this morning who might be interested in doing business with you?
Bring a checkbook. No, I'm just kidding. The most important thing is please keep coming and talking to us. Our office is in downtown Knoxville, so please feel free to drop by and let us learn what are the different technologies of interest. It may be that you all are working in a different area, and we may have technologies in a completely different space, but there may be a fit there. So, when you come and talk to us, and we may not have something, but we can keep you as a list of potential people to contact, that when a technology does walk into our door, we can talk to you all. We also are very open to our license terms. We are willing to walk and meet more than halfway, or at least halfway. There are a few things as an entity of the state we cannot change, but barring that, most of the things that we can, we are more than happy to work with our licensees and meet them.
John, I know that the National Institute for Hometown Security is really focused on commercializing the results of the research. So for the audience today, what advice would you give them on how best to approach you and work with you?
Well, I would say make us aware of your capabilities, your technical capabilities. Our typical model is we go with the very, very deep research capabilities. We kind of have a matrix of technical capabilities, if you will. So whenever we're connecting the dots, that the requirement is this, we'll search through our capabilities and say, this is the best capability, best way to achieve that. So I would say make us aware of your deep technical capabilities, be it if you're a research institution or a company. Typically the companies that are also successful in those technologies would be the likely partner in the event, and we do that orchestration to some extent. Connecting up, we can kind of map those together, that we need this capability and this capability, and here's the team, and here's the likely company if the company isn't already tied into the research capabilities. The smaller companies typically spin out of the researchers, but overall I would say make us aware of your technical capabilities. Then we have you available when that need comes up, and when we connect the dots, we may call on you to be a teaming partner in a development effort.
Tom, my sense is that you and your team are making real progress at Y12, but you are a national security complex. So for the audience today, how best could they work with you?
Well, to echo the comments earlier, in the licensing group, commercialization group, we're a service organization. And I'm going to tell the entrepreneurs in the group something that they have as part of their DNA. Don't be patient. Have high expectations of what you want the performance to be from the group. Because of the huge size of our group, which is 2 people, we can be very responsive. And the second is, and this is contrary to the DNA of an entrepreneur, is, part of what we do when we work out a license agreement is we have an expectation as part of our due diligence that we get a marketing plan. And by the nature of the entrepreneurs, they tend to be pretty aggressive and say, let me make something. We plan to be at $20 million or $40 million in 3 years. Well, I'm going to tell you a secret. Just for this group, because of your affiliation with Tech 2020, we take that and we calculate the license fees based on that. And so inevitably what happens at the end of 2 years, when you haven't, as was said yesterday, you haven't quite made those numbers, we at the end of that period say, well, but you said 20 million and you're at 2 million, you still owe us X. So one of the things that you might want to keep in your shaving kit when you're going through this license agreement is, what is it really going to be? We're not bankers. You don't have to impress us to get more money. We're a little bit different than going someplace else for a license. We want to work with you and understand what the real end goal is going to be and help you get there.
So mark your bat and clean up. What advice would you give the audience in approaching the Oak Ridge National Laboratory?
The first thing I would I would say is remember what Tom Berg just said. It's really important. I'll be as quick as I can. Just quickly. I came into the technology transfer office at the lab in 2000. And at that time, the mantra was that the biggest barrier to commercialization of technologies from the laboratory, from the university, wherever, the sort of high-tech entrepreneurialism was lack of access to capital. And I just assumed that was true and bought into it and sang the same song for several years until I finally figured out it was absolutely false. What we see on our end, if I listed today the top 5 reasons entrepreneurial technology-based companies fail, lack of access to capital wouldn't be on the list. The 2 big things you have to keep in mind is, one, you have to come and engage with us, in particular with our scientists and engineers, and understand the technologies we're talking about, and in particular understand how that technology underpins a product that can be sold in the marketplace and either displace an existing product or fill an unfulfilled need or somehow generate revenue for you. That's the real missing piece that I see from people who come to the laboratory wanting to be entrepreneurs, wanting to license technologies, is the lack of the ability to understand how this technology gets converted into a product that you actually sell to people and make money. And that's the way you build a business. Just licensing the technology, unless your interest is simply in living on SBIR grants for a couple of years, gets you nothing if you can't make a product from it and sell it to somebody. So that's number one. And the second thing is you have to have a capable management team in place that can execute on that plan to take that technology and make a product out of it and sell it to somebody. Never discount the value of experienced management. It's a critical piece. So some years ago I went to an event similar to this up in Kentucky and was just chatting casually with a fellow from the venture capital industry in the lobby, and he taught me the most valuable lesson I probably learned in technology transfer since I've been here. We were talking about the venture capital view of technologies and that sort of thing, and he said, well, the thing is, venture capital people don't give a damn about technologies. All they care about is markets and management. So what I described to you earlier is you got to understand how your product's going to go to market, how this technology makes a product, how it makes money in the market, and you have to have a management team in place that can capitalize on that. If that happens, you will have access to capital. because you'll have what it takes to get it. So the real problem in 2000 was not lack of capital. It's just that there's not much stupid money running around. That money is going to go to the people who have a good business plan and understand their market. That's my advice.
And it's good advice. So as we conclude, let me echo what this panel has said. You all represent technology pull for us. Identify a market need, find pain in the marketplace, and then work with us to investigate how the technologies that these folks represent might help you do that. Okay? That's the biggest thing you can do. Tommy, you have a question? Oh, we're going to have a whole panel question. This is great.
Wondering if you could induce your panel to talk a little bit about typical royalty rates and licensing terms. A very interesting subject.
I'm not sure I can induce them, but I'll pass the question along.
Maybe you can beat them into it.
Anybody want to bite at that? Maha said she will.
Mark, I pointed out to
We are
Mark.
part of Mark.
Oh, they were pointing at Mark. Okay.
I just told this story the other day. Someone asked me recently, what does a typical license look like? And I said, if I ever do one, I will let you know. True. They're all different, and the reason is every technology underpins a different product that penetrates a different sector of the market and generates a different margin and has different impact. And so I'm not a big fan of one-size-fits-all licensing. If I do that, I'm either going to shortchange you or I'm going to shortchange my inventor. I think the market ought to set the terms, and so, but we're not onerous about it. As Tom, I think, mentioned, we want to see a business plan. We want some realistic projections of your revenues if you come in, and we'll sit down and quickly negotiate an agreement that says, if you're successful and if you meet these targets, you'll make a lot of money, and we'll make a little bit of money, and everybody will be happy. Typically, I mean, there's all kinds of numbers you can get for average royalty rates and all those kinds of things. But the royalty rate's different on a product that has a 5% margin versus a 40% margin. Software royalty rates are sometimes 15, 20%. Typical patent license royalty rates are more in the 2 to 5% range. But again, it depends on the market. And making one size fit all may guarantee that you're never successful. That's my view of it. Others may feel differently.
Yeah, kind of my tongue-in-cheek answer. They're about 25 pages. Yeah, but agreeing with Mark, and I don't think we'd want them to be typical in the sense that, for us, for DOE, the boilerplate's basically all the same, and what you really care about are the business terms and conditions, right? So what the upfront is and that sort of thing. It's in our interest. Our metrics are more based on, are you successful, than especially in the upfront part, as opposed to how much money are we going to make. Now, we all want to make each other obscenely rich, right? But we know in order to do that you have to be successful in doing that. But I agree with Mark that, I think in all our patents, they're all different because they need to be.
Anyone else? I think we've...
Can I just add one thought? We have no motivation to do anything but see you make as much money as you can make. We're all motivated to see that happen. Because that means, number one, it means you're successful. And if you make money, we're going to make a little money, and our inventors are going to share in that.
So I would agree with that. I mean, everybody on this stage is interested in a win-win. Okay? That's what successful technology transfer is all about. You win, we'll win a little bit, you win a lot, you'll come back to do business again. That's the goal here. Well, listen, thank you very, very much. I think you've done a great job talking about a subject that's really of interest to this audience. So please join me in thanking our panelists.
Okay, thanks everybody. All right, let me tell you a little bit about what's going to happen next. The workshops, we've got